Hello dear students, in today's video we are going to discuss the next part of this lesson, motion. So in today's part we will discuss mainly about how can we represent motion of different types, uniform motion, non-uniform motion using graph. So we already came to know about how to draw a graph. There are two axes, one is called x-axis and another is called y-axis. So first let us consider about how can we draw a graph for an object traveling with uniform speed. Already we discussed about what you mean by uniform speed. If equal distance, if an object travel equal distances in equal intervals of time, equal distances in equal intervals of time. So such a motion is known as a uniform motion. Or in this case, we are going to draw a graph, that is distance time graph for an object moving with uniform speed. So that means if an object covers say 10 meter in 1 second and the next 10 meter in another 1 second. So what will happen? It will cover equal distance in equal intervals of time. So what will be its speed? Speed we can calculate. Speed is equal to distance travelled upon time taken. So what is distance travelled? 10 meter. Time taken is 1 second. So after 1 second it will cover 10 meter and the next 1 second again 10 meter. So equal distances it will cover at equal intervals of time. So what will happen? Speed will remain the same. So speed will remain 10 meter per second. So now let us draw a graph. Say I have drawn a graph. X-axis I have taken time in hours and y-axis I have taken distance in kilometers. Time in hours and distance in kilometers. So as we know, origin, this is the origin we are marking 0. Then at this point I have drawn 5 hours, then 10 stands for 10 hours, then 15 stands for 15 hours, then 20 stands for 20 hours. Since I have taken time in hours. And similarly distance, here distance I have taken along the y-axis. So distance I have taken in kilometers. For easiness I have taken first one as 50 kilometer, then second 100 kilometer, third 150 kilometer, fourth one 200 kilometer. So then I have just drawn a straight line graph that is passing through the origin. So this will happen in the case of a distance time graph of an object moving with uniform speed. So we know that speed remains constant or the object covers equal distance in equal intervals of time. Let us now look at 0 to 5 hours. After 5 hours what happens? The object is covering 50 kilometers. Say after 10 hours how long it will cover? It will cover 100 kilometers. After 10 hours the object is covering 100 kilometers. After 15 hours the object is covering 150 kilometers. After 20 hours the object is covering 200 kilometers. So if you take then now using this graph we need to calculate what the distance traveled. For this we can calculate if you take this slope of this particular graph. How you take the slope of this particular graph? So you can mark a particular any 2 points. Say I am marking these 2 points. So now we need to calculate the speed with which this particular object is traveling using this graph. For that I need to mark 2 points on the graph. Say I have taken these 2 extreme points. Say I am making then drawing perpendicular to x-axis from this particular point. So you take it as A, B, and from this point I am drawing a perpendicular to x-axis and also to y-axis. And from point B again I am drawing one perpendicular to x-axis and again drawing to perpendicular to y-axis. Then, so where these two things meet, you can see from point A what I have drawn, that is meeting 15 hours. Then corresponding line perpendicular which I drawn to the x-axis, that is meeting at 150 kilometer. Then from B 20 and from here 200 kilometer. And say now let us calculate speed with which, what is the speed with which this particular object is traveling. Say what is speed? Speed we already studied. What is speed? Speed is distance traveled upon time taken. So how will you calculate distance traveled? Distance traveled is the we can take, say, this at this particular point, the corresponding point, the perpendicular from A to y axis, that I am taking as S1, and the perpendicular from B to y axis, that I am taking as S2. So just to I am giving the denomination in order to while taking the value it will be useful. Then from B to x axis, that we are taking T2, and from A we are taking it as T1. 15 we are taking it as T1. Now we can see, so what is speed? Distance traveled upon time taken. From the graph we can see that what is distance traveled, we can get, we have taken these 2 points, so distance traveled will be this much. Then that will be S2 minus S1. S2 is here, S2 minus S1. Between these 2 points, the distance traveled between these 2 points will be S2 minus S1, and the time taken for that particular journey will be T2 minus T1. So we can write what is S2. S2 is 200. The distance traveled corresponding to the point B is 200. Then minus, then S1, the distance traveled corresponding to the point A, that is 150. 200 minus 150 divided by T2. What is T2? 20, and A corresponding T1 is 15. 20 minus 15. So what is 200 minus 150? You will get 15, and 20 minus 15 you will get 5. 50 by 5 you will get 10 kilometer per hour. So the speed you can calculate the same way you can calculate the speed between these 2 points, or these 2 points, or these two this point. So in all these cases you will get the speed remain same. So that's why this particular graph is known as graph for distance time graph for uniform motion. An object traveling with uniform speed, so that will remain a straight line that will be passing through the origin. And now let's look at this distance time graph for non-uniform motion. So what do you mean by? So definitely it will not be a straight line. Clear? So here equal distances, the object was covering equal distances in equal intervals of time. But in this situation what is happening? The object is not covering equal distances in equal intervals of time. Object is covering in non-uniform speed or non-uniform motion. What is happening? The object is covering unequal distances in equal intervals of time. Say for example, we can look at this particular point for understanding. For along x-axis I have taken time in hours, distance I have taken along y-axis and in kilometers. So as we look at x-axis, you can see I have drawn 5 hours, 10, 15, 20, 25. Y-axis I have taken 100 kilometer, 200 kilometer, 300, 400, 500, 600, etc. See what is happening. The object is starting from the particular point, say at the time 0. So after 5 hours, what happens? The distance travel is around just say 20 kilometer. So after 5 hours, the object is covering approximately 20 kilometers only. So then 5 to 10 hours, within 5 to 10 hours, what is happening again? One more 5 kilometer, one more. Within the next 5 hours, the object is somewhat covering about 100 kilometers. So definitely you can see within the first 5 hours, the object is covering only 20 kilometers. I mean for corresponding, we can see 20 divided by 4. So what will you get? Sorry, 20 divided by 5 will get 4 kilometer per hour. And at the same time, you can see the next 5 hours it's covering 100 kilometers. See, 100 divided by 5, you get 20 kilometer per hour. So the speed is changing in this situation, and the next we can see it's again increasing very high. So such a case where the object is not covering equal distances in equal intervals of time, and such type of motion is known as non-uniform motion. The object is moving with non-uniform speed. In such a case, the graph will be in the form of a curve. Okay, you need to mention that you can calculate the speed using the same technique. So collect any point, select any 2 points and draw perpendicular. You can follow the same method. Okay, just pause back and just view this particular portion again. The same method we can calculate. Say here we can see the graph is not a straight line. So that indicates the object is moving with non-uniform speed. So now we got understood these two sections. Distance time graph for uniform motion and distance time graph for non-uniform motion. So now let us look at the next type of graph, that is velocity time graph. So what do you mean by velocity time graph? In velocity time graph we are using y-axis we are taking velocity. Earlier we took what? Distance. Distance time graph. Why it is known as distance time graph? Because along one axis we are taking distance, and along another axis we are taking time. That's why the graph name is distance time graph. And the next graph is velocity time graph. What do you mean by velocity time graph? The one axis, say along y-axis we are taking velocity, and along x-axis we are taking time. So that's why it is known as velocity time graph. Say for example, so first I have drawn a graph for velocity time graph for an object in uniform motion. So what do you mean by uniform motion? Velocity time graph. We are drawing velocity time graph. See, uniform speed. The speed will remain same. So as we discussed in the uniform speed earlier, the speed will remain constant. So we can see. So I have drawn the graph for you. So on x-axis I have taken time in hours, and y-axis I have taken velocity in kilometer per hour. Say 40 kilometer per hour. See, an object is moving with 40 kilometer per hour. So from the starting point itself, the object is moving. At the point when we start considering that object, the object is moving with a speed of 40 kilometer per hour. See, if you see at this particular time, if you 40 kilometer per hour, that speed remains the constant. Speed remains the same throughout the journey. Suppose if you want to calculate, say between the two time intervals, say 8 hours and 2 hours. These are the 2 points of which we are going to calculate the distance travel during this particular interval. From distance time graph we calculated what? Speed of the object, and from velocity time graph we are calculating the distance travel or the displacement of that particular object. So we already know that velocity is what? Displacement into displacement divided by time, or displacement is equal to what? Velocity into time, or velocity into time. So you can see what is velocity here? 40 kilometer per hour. So the object is moving with uniform velocity. So the object is moving with uniform velocity, or it is moving with uniform motion. The speed or velocity of the object will remain constant. So we are taking the value v is 40 kilometer per hour. And at the same time, we can see what is time. The time gap for our consideration is T2 is 8 hours and T1 is 2 hours. So as earlier we did, just you can see time we can calculate as T2 minus T1. Final time, that is T2. Final minus initial. So what is T2? 8, and T1 is what? 2 hours. After 2 hours we are considering. So you can consider from the starting also. Then 40 into 8 minus 2, you will get 40 into 6. So 40 into 6, you will get 240 kilometers. So during this particular portion, so while the object was traveling between 2 hours, that means not from 0 hour, from 2 hours to 8 hours, if an object is moving with a speed of 40 km per hour, it will cover 240 km. So that is called the displacement. So we can calculate displacement of an object which is moving in a uniform motion from its velocity time graph. See, using this method. I hope you understood. If anybody have got doubt, you can discuss, you can ask to me. You just watch this video again. Okay. And the next graph that we are going to discuss is the velocity time graph for uniform acceleration. So what do you mean by uniform acceleration? If an object is increasing its speed consistently, say you can say, so initially the object was moving at say 5 km per hour, then after 1 hour or after 1 second, after 5 seconds, after a definite time interval, if the object is increasing its speed to say 10 km per hour, and the next, if it is increasing its speed to 15 km per hour, see what happens in all this case, the speed is increasing continuously. So we can see that from at the starting of the journey, the speed of the object was, look at this particular graph, along x-axis I have taken time I have taken along x-axis. So it is in seconds or hours you can take, or in minutes, and velocity I have taken in meter per second. So for easiness we can take that particular thing. See, now we are considering velocity time graph for uniform acceleration. Acceleration means what? Rate of change of velocity. So already we defined that acceleration is what? Rate of change of velocity. That is final velocity minus initial velocity upon time taken. So this is what our acceleration. So acceleration you can see. Acceleration, how can we calculate acceleration? Acceleration is equal to final velocity minus initial velocity upon time taken for that particular change. So if an object is moving with uniform acceleration, so its speed will increase continuously after a regular interval of time. See, as you can see here, so at the start of the journey, the object is moving from at that particular origin, so with 0 meter per second, the speed is 0, then slowly it increases its speed and continuously. Say we can say 5 meter per second, then 10 meter per second, then 15, then 20. So it increases just like this. So as we know already that speed is distance upon time, or distance travel we can calculate by multiplying velocity into time. So in this case, in earlier case we calculated the area of this particular rectangular portion. So here, if you consider these 2 points, here we will get the as you draw, you will get 2 regions, one rectangle as well as one triangle. So if you calculate the total area under this 2 particular points, these two reference points, you will get the total displacement of the object, or total distance traveled by the object. As we can see, distance traveled or displacement of the object is velocity into time. So velocity you will get from this particular point, the velocity, initial velocity as well as final velocity, then, and also you can calculate it by calculating the area of the triangle plus summing, or adding the area of the triangle plus area of the rectangle. What is the area of the triangle? Half into base into height. This is the base of the triangle and this is the height of the triangle. So you can put any particular numerical value and you can prove that. Okay. While doing numericals, we will discuss this particular problem again. Then S is equal to half into base into height, then plus area of the rectangle, that is length into breadth. So Using this equation, we can calculate the distance traveled by the object under velocity time graph of an object moving with uniform acceleration. That means the acceleration is continuously increasing. The similar graph that we have seen here. Here the object is moving with uniform speed. Speed remains constant. Here we have taken distance and time. Here we are taking velocity and time. So this is the velocity time graph for uniform acceleration. It will be a straight line passing through the origin. So I hope you understood. Just to rewind this video, watch it 2 or 3 times and understand these particular terms and concepts. Okay, study well and stay safe. Thank you.